Good morning, everyone. Welcome to the video lecture series of Power Electronics and Instrumentation, module number 1, thyristor gate characteristics. In the last video lecture, we have gone through something about the SCR and its VI characteristics of SCR. Okay, so in the theory or the concept of SCR says that okay, we should apply a minimum leakage current or the required leakage current, or we can say as a gate current. Okay, it is being denoted by the current Ig. Okay, so how much amount of current we apply to the gate terminal or the supply to the gate terminal, it will make our SCR to turn on in a better manner. Okay, if we apply very less amount of gate voltage, then there is a possibility that even though your SCR is in the on state, okay, it will not be in the conduction mode, it will be in the forward blocking region. Okay, so that is how we have seen in our previous video lecture as how the SCR has been characteristics of SCR is uh, represents its operation. Okay, that is the another very important question from the exam point of view. Okay, so today we will see something more in detail about the thyristor gate characteristics. Okay, we will not be focusing on the anode and cathode terminal. We only focus on the gate characteristics. Okay, so gate is the one of the very important terminal of the SCR. Okay, we have three terminals in the SCR. One is anode, cathode, and gate. Okay, so always remember the flow of charge or the flow of current. Okay, or the flow of electrons will be from anode to cathode in SCR. This is as usual like your normal PN junction diode. Okay, but until and unless you do not apply the sufficient amount of gate current, your SCR will not turn on. Okay, so let us today go through in detail about the gate characteristics of the thyristor or SCR. Okay, so if you look at this particular graph here, which is shown, which is around along the current Ig. Okay, current Ig is nothing but it's a gate current. Okay, this graph is plotted gate current, okay, versus the gate voltage. Okay, here we have the gate source voltage. Here you can see it is a gate source voltage. Gate source voltage in the sense, let me show you the symbol of SCR, which is represented by this particular symbol. It is just like your diode, only the thing is a terminal extra is a gate. Okay, this is my anode, this is the gate terminal, and this is cathode. This is cathode. Sometimes we call the anode as my source. Okay, and this cathode we call it as a destination. Okay, and the other words. Okay, this is the source, gate, and or sometimes we can call it as a D is represented by drain also. Okay, source, or you can drain, or this is my gate. Okay, so this graph is with respect to the Ig, that is the gate current which we apply at this particular point. Okay, versus the voltage, that is the gate voltage. Okay, which is nothing but your gate source voltage. Gate source voltage is nothing but this particular voltage which we apply at this here. Okay, so this becomes my VGS. VGS is nothing but gate source voltage. Okay, it's a gate source voltage. Okay, so this is my voltage which I will be applying at this particular point. Okay, and in this particular graph, okay, you can see there are some cross sections. Okay, you can see there is an exponential increase in the voltage, or sorry, exponentially increase in the current, which is shown by this is M. Okay, there is one more exponentially increase in the current, we represent it by N. Okay, and this is my constant PG, and this is my load line. You can see there is one diagonal line which has been drawn from the point H to point D. Okay, one line which is an inclined line, and we have one like S1 source voltage also. Okay, or source current S1. We have S which is shown here, and we have one more S2. Okay, so what this gate characteristics says is in this particular graph, okay, the gate voltage is plotted with respect to the gate current. Okay, in the above characteristic, that is what I just said, that the current which is applied here is the gate voltage versus the gate current. Okay, Ig versus Vg. Okay, the first line says. Okay, then Ig max is the maximum current. Okay, maximum gate current. Okay, Ig is nothing but, or there is one voltage here which is represented as the Ig max. Okay, this Ig max is nothing but it is your maximum gate current. Maximum gate current is nothing but once you apply the gate current or the gate voltage, gate some voltage at the gate terminal. Okay, it will be having its limit. Okay, limit in current and voltage. Okay, we call it as a maximum gate current. Okay, so beyond, if you apply the voltage beyond that maximum gate current, okay, there is a possibility that your SCR will get damaged. Okay, so the maximum gate current is nothing but which is shown at this particular point. Okay, Ig max, you can see here, this is Ig maximum and this is my Ig minimum here. This is Ig minimum and this is Ig maximum. Okay, in the sense, these two dotted lines which you can see here. Okay, this is my minimum and this is my maximum. Okay, this gate characteristics says that once I start to apply the current to the gate terminal or the voltage to gate source voltage to the SCR. Okay, once it reaches to its minimum value. Okay, once it reaches to its minimum value, what graph I'm getting. Okay, or once if I reach to my maximum level of my gate current, how much amount of voltage I can draw at the output side. Okay, so therefore the gate voltage is plotted with respect to the gate current, which is shown in the above characteristics. Okay, so the Ig max, it is nothing but the maximum gate current that can flow through the thyristor without damaging. That is what the more important. Okay, I cannot exceed my gate current. If I exceed my gate current, for example, the SCR has the maximum gate current which can withstand is, for example, around some 10 amperes of current. Okay, I is equal to 10 ampere. This is just an example. Okay, I is equal to 10 amperes of current. The SCR can withstand. If I increase something like 10.1 ampere, okay, so this 0.1 ampere will damage your SCR. It will damage your SCR because you are crossing the limits or the basic readings or the recommendation by the manufacturer. You are crossing the limits, you are applying the voltage beyond the limits, then it will damage your SCR. Okay, this is with respect to the current. Okay, similarly, we have one more voltage reading called as a Vg max. This is called as a maximum gate voltage. So therefore, it is similarly the Vg maximum is nothing but it's a gate voltage to be applied. Okay, so therefore, minimum Vg and Ig minimum are the minimum gate voltage and the gate current below which the transistor will not be turned on. It will not be turned on beyond minimum. Beyond minimum, I will just show you one. I will just quote one example here. Okay, just look at this line. Okay, and this is one line and this is another line. Okay, so the first line I tell it as a minimum. Okay, and the second line is nothing but your maximum. Okay, so for example, okay, if this is my 0 point here, okay, this is my 0 point here, or my zero start at this particular point. Okay, so if I apply the gate current, which current here, this is my G, that is the gate current and gate voltage, both we are considering. Okay, if I take my gate current or my gate voltage, okay, gate current and gate voltage less than this minimum, means I will start applying my gate current like this. If it is less than minimum, if it is less than the minimum, then my SCR will not turn on. Beyond less than minimum. Okay, or if I take with respect to the voltage, okay, if I take with respect to the voltage Vg minimum and Vg maximum. Okay, for example, let's say there is this point. So if when I start applying the voltage like this, if it is minimum or if it is not crossing the minimum line of the current as well as the minimum line of the voltage, I'll draw one more line here. I'll draw one more line. So two cross marks we can see here. This is first cross mark and this is second cross mark. So the first cross mark is with respect to the current and the second is with respect to the voltage. Okay. So once I apply the current in this direction, if it is less than 1, your SCR will not turn on. If I start applying the voltage at this particular and towards this direction, if it is less than this point, okay, your SCR will not turn on. Okay, so therefore, if you want to study the gate characteristics of the SCR, then you should know the minimum operation, which says that the minimum, okay, or the gate current and the gate voltage, if they are less than minimum, that is what the sentence says. If both the current and voltages are less than the minimum voltage and current, then your SCR will not turn on. Your SCR will not turn on. Then what I should do? I should increase my gate current and gate voltage beyond minimum or at least minimum voltages. That is minimum gate voltage and minimum gate current. Okay. So therefore, once you cross the minimum lines, okay, once you cross the minimum lines like this, if you're just here, if you cross the current above the minimum line or at this at least minimum line and also the voltage at beyond like this too, then your SCR will turn on. Your SCR will turn on. So what is the second case? The second case says that you should apply the minimum gate current and the minimum gate voltages. Okay, but it should be greater than minimum point. It should not be less than minimum. It should be greater than minimum. But the condition is that it should not be greater than the maximum value. It should not be greater than the maximum value. In the sense, both the gate current and the gate voltage should not cross these 2 points, because this point is my maximum point. Okay, if you just apply your gate current and gate voltage till here and till here, okay, like this, gate current and gate voltage, and if you are reaching both in the maximum, that is you are reaching it to the maximum value of voltage and the maximum value of current, okay, then still your SCR is turned on. But if you cross beyond this cross marks, that is nothing but the maximum point of current and the maximum point of voltage, then your SCR, it will not, what it will happen, it will damage. It will damage. Okay, so this is what the gate characteristic says. The gate characteristic says that if the voltages are less than minimum, that is nothing but 0 to less 0, okay, less than minimum, what will happen? Your SCR is off. What is the second point? That if it is minimum, okay, like this, greater than or equal to minimum, but it should be less than what? Less than maximum. Okay, what will happen to the SCR? It will be turned. It is turned on. It is turned on. The third condition is if they are greater than, okay, if the gate current IG is nothing but gate current and the gate voltage, if they are greater than the maximum gate current and maximum gate voltage, then what it will happen? It is damage. It will damage. Okay, so this is the conditions. These conditions are very important. This is what the graph says. Okay, so with respect to these three conditions, your SCR will be turning on and turning off, and it will damage if you are trying to increase your gate voltages. Okay, so this is the very important point of aspect which should be considered okay, when you are trying to operate your SCR in your practical cases, okay, because we have the many various practicals we can do with respect to the SCR, okay, in with example to taking it to example or the application of the speed control of your AC motor or the speed control of your DC motor, okay, or speed control of a fan, normal fan also, okay, there you should consider these aspects, that the voltages which we applied at the gate terminal, either with respect to the voltage or with respect to the gate current, okay, yeah, it should be we should keep in mind that we should not exceed the maximum current or the maximum voltage. If we exceed, it will damage your application, it will damage your fan, it will damage your motor, okay. But if you again if you consider these two current and voltages less than the minimum value, required minimum value, then your device will never turn on, okay. Just to turn on your device, okay, it should be at least equal to minimum and less than the maximum value, then it will be on for that particular range of current and for that particular range of voltages, okay. So this is how the characteristics of the gate characteristics of SCR will work. Okay, with respect to this gate characteristics of SCR, okay, we have something very important requirements which we should consider for which should consider when we go to the example point of view. Okay, so the requirements of the gate drive says that the maximum gate power should not be exceeded by the gate drive. Okay, otherwise your thyristor will damage. This is the first point. Okay, the second point says that the gate voltage and the current and the gate voltage should be within the limits specified by the gate characteristics for the successful turn on. That is what I just said, those three conditions. Okay, those three conditions. The third point says the width of the pulse should be sufficient to turn on the thyristor successfully. The width is nothing but the pulse width, okay, on and off pulse, okay. The pulse width should be at least minimum, okay. It should be sufficient to turn on the SCR, okay. If the pulse width is very small, okay, then it becomes very difficult for the applicator to turn on the thyristor. Okay, the fourth point says the gate drive should be isolated electrically from the thyristor. This avoids any damage to the triggering circuit if in case the thyristor is damaged. This is the fourth point. That is nothing but we should provide some kind of isolation for the gate drive. Okay, else your whole SCR will get damaged. Okay, the fifth point is the gate drive should not exceed the permissible negative gate to cathode voltage. Otherwise, the thyristor is damaged. The last point is the gate drive circuit should not sink current out of the thyristor even after the turn on. That is nothing but even if the SCR is turned on, there should not be excess amount of the gate current which should be getting synced. Synced is nothing but it should be getting dropped. Otherwise, your SCR will not turn on properly and it will take it you to the off state. Okay, so this is how the gate characteristics of the thyristor is studied in detail. Okay, again we can go and study how to turn on the SCR. Okay, we have just seen the gate characteristics of SCR. Okay, but how to apply the gate current, how to turn on the gate current, what are the various mechanisms, okay, to turn on the SCR. Okay, so those things can be studied in the next video lectures. Okay, so with this I will conclude my today's topic of, that is, the gate characteristics of SCR. Thank you.